Hello students, today we're going to discuss JEE 2025 question from most important and basic chapter of mechanics, that is motion in straight line, or we call it as kinematics. So we're going to discuss all the question in detail, so don't miss this video. And to explore more regarding physics, join in our Instagram page and WhatsApp channel. Links are in the description. So now let us get into the video. We'll see the first question. A sportsman runs along a circular track of radius r such that he transfers the path AB, the distance travel and displacement. So here a sportsman is running along a circular path, okay, of radius r. Now we have to find its distance and displacement. Okay, so it's moving along a circular track. So distance means a path covered by an observer. Okay, so for one complete track, we can take the distance, that is circumference of a circle, which is 2 pi r. So he covered the path along A to B, B to A, again A to B. So he completed 1.5 circle. So 1.5 circle means 3 by 2 of 2 pi r. Okay. So 2 will get cancelled. Balance. Distance is equal to 3 pi r. So we found the distance. And then we have to see displacement. Displacement means a shortest path from initial point to the final point. So initial point is A, final point is B. So this is the initial point, this is the final point. A shortest path means always it will be a straight line. Okay. So this will be the diameter of a circle, that is twice the radius r and r. So the displacement of a sportsman is equal to twice the radius, which is 2r. Okay. So distance is 3 pi r and displacement is 2r. Option 4 is the right answer. Next one, it's a most important question. A person traveling on a straight line moves with a uniform velocity v1 at a distance x with uniform velocity v2 for next 3 by 2 x distance. The average velocity in its motion is 50 by 7 meter per second. They have given the value for v1. v1 is 5 meter per second. They are asking v2. So first we'll take the given data. First, a person is traveling in a straight line. They covered a distance x with velocity v1. They didn't give the time interval, so we'll take it as t1. And next distance is 3 by 2x, velocity is v2 and time interval is t2. Is it okay? So they have given the average velocity. So the general formula for average velocity is equal to total displacement by total time. Is it okay? So we know the displacement, that is x and 3 by 2x. So you can sum up that one. So total time we have to find, that is t1 plus t2. So for that we can use a general formula. We know velocity is equal to displacement by time. So we can take time is equal to displacement by velocity. So here in the place of t1 is equal to displacement is x by velocity v1. Again for time t2 is equal to the displacement is 3 by 2x by velocity v2. If we want, you can take 2 to the denominator. So 3x by 2v2. Is it okay? So we got t1 and t2. So we can substitute in the general formula. So here the average velocity is 50 by 7. So 50 by 7 is equal to total displacement is x plus 3 by 2x. So you can substitute as x plus 3 by 2x and total time is t1 plus t2. Is it okay? So 50 by 7 is equal to, if we cross multiply, we'll get it as 5x by 2. In the place of t1, we can substitute x by v1. In the place of t2, we can substitute 3x by v2. Okay. So in denominator, we can take x as common, so that, and also this will become 1 and it becomes 10. So 10 by 7 is equal to x by 2. In denominator, we can take x as common. Balance 1 by, we have v1, we know the value for v1, which is 5. So 5 plus 3 by v2. Is it okay? So here x will get cancelled. So this 2 will come to the denominator. So we can write it as 10 by 7 is equal to 1 by 2 into 1 by 5 plus 3 by v2. Is it okay? So if we cross multiply, you will write it as 20 into 1 by 5 plus 3 by v2 is equal to 7. Is it okay? So now we can reform the equation so we can take 20 to the opposite side. So 1 by 5 plus 3 by v2 is equal to 7 by 20. So we can take 1 by 5 to the opposite side. So 3 by V2 is equal to 7 by 20 minus 1 by 5. So here you can multiply and divide by 4. So 4 and multiply by 4. So 7 minus 4 is 3. So 3 by 20 is equal to 3 by V2. So we can cancel 3, 3. Balance V2 is equal to 20 meter per second. Okay. So the answer is 20 meter per second. We'll see the next question. They have given the position of a particle. The C0 and C are constant. So they ask us to find which statement is correct. So the options are deal with acceleration and velocity. So we'll find acceleration velocity. For that, we'll take position equation. That is x is equal to C0 into t square minus 2 plus c into t minus 2 the whole square. Okay. So if you're differentiating position with respect to time, we will get velocity. Okay. So velocity is equal to C naught into, so here we have power 1. So 1 into t square minus 2. So here 1 minus 1 will become 0 into, if you're differentiating t square, that will become 2t. Okay. So plus c into 2 into t minus 2, the whole power 2 minus 1 will become 1. So if you're differentiating t, that also will become 1. Okay. So we can take velocity is equal to, so 2 C naught t. So anything power 0, that will become 1. So this is 1 plus again 2c into t minus 2. So this is velocity. So now we have to find the initial velocity. So if it's initial velocity means time t is equal to 0. So if you're substituting time t is equal to 0 means ultimately all the term will go to 0. So the velocity is 0. Okay. So option 3 is incorrect. Okay. Then we will check acceleration. Again, if you're differentiating velocity with respect to time, we will get acceleration A, that is equal to, if you're differentiating this term means, you will get it as 2c0 where t will become 1 plus 2c, this is power 1. So this will become 1 into t minus 2 the whole power 0. Again, if you're differentiating t, that will become 1. Okay. So we can rewrite as 2c0 plus 2 into c, this will become 1. Okay. So balance, if you're taking 2 as common, c plus c naught. Okay, so this is acceleration. So we'll check the option. Option 4 is the right answer. So next one, which of the following curve possibly represent one dimension motion of a particle? So we have to check which graphs are possible for 1D, that is one dimension. So first we'll start with A. So phase time graph, phase can be negative. So it's possible for 1D, so A is possible. So coming to B, it's velocity displacement graph. So velocity is a vector quantity, it can be positive and negative. Same way, displacement is also a vector quantity, it can be positive and also it can be negative. So B is also possible. And third one, velocity time graph. So velocity is a vector, it can be positive and negative, but time can never be negative. Always the time will be positive only. So here the graph is in the negative position. So option C is invalid. It's not possible in 1D. Okay. And last one, distance time graph. So distance is scalar quantity. It can be only positive. So D is possible. So A, B and D is possible. Option 1 is the right answer. So we'll see the last question. The displacement x versus time graph is shown in the figure. Okay. So we have to check which options are correct. Okay. So displacement time graph. We'll start with A. The average velocity during 0 to 3 seconds is 10 meter per second. Okay. So we'll check the average velocity. Average velocity formula is displacement by time. Okay. For 0 to 3 seconds. So at 0 second the position is 0. At 3 second the position is 5. So the displacement is 5 minus 0 and for 3 seconds, so by 3. So 5 by 3, so the average velocity is 5 by 3. They have given it as 10 meter per second, so A is incorrect. So we'll check for B. Average velocity during 3 to 5 seconds is 0 meter per second. Okay. So again we'll check for 3 to 5 seconds. So at 3 second the position is 5 and 5 second also the position is 5 only. So the displacement is 5 minus 5 and time period is 3 to 5, this is 2. So 5 minus 5, that goes to 0. So it's 0 meter per second. So B is correct. And then we'll check for C. The instantaneous velocity at time t is equal to 2 seconds is 5 meter per second. So if we want to take instantaneous velocity means we have to take a slope here. So here we will take a slope. Okay. We'll take this slope. Okay. So third one for option C, velocity is equal to slope means change in y-axis by change in x-axis. So here the change in y-axis is 5 to 0, that will be 5, and change in x-axis is 2 to 3 seconds, that will become 1. Okay, that is 5 meter per second. So option 3 is correct. So that is 5 meter per second. We'll go for D. The average velocity during 5 to 7 seconds and instantaneous velocity at time t is equal to 6.5 seconds are equal. Okay, so now we have to find two things. Average velocity during 5 to 7 seconds. So 5 to 7 second. Okay, so for option D, average velocity for 5 to 7 second. For 5 second, the position is 5. For 7th second, the position is 0. So the displacement is 5 by 5 to 7 second. This is true. So 5 by 2, you will get it as 2.5 meter per second. Fine. So next one, we have to find instantaneous velocity at time t is equal to 6.5 second. So 6.5 second means here. So we have to find the instantaneous velocity. So here I am going to take a slope. Okay. So we'll take the slope here. So V is equal to change in x by change in time, that is equal to, so you can see the y-axis. So 10 to 0. So y-axis is 10, and for time 6 to 7, that is 1 second. Okay. So here it is 10 meter per second. So you can check here, average velocity is 2.5 for 5 to 7 second and instantaneous velocity is 10 meter per second, which is not equal. Okay. So D statement is invalid, that is wrong. And last one, we'll check E. So the average velocity from time t is equal to 0 to time t is equal to 9 is 0. Okay, so average velocity, we'll find displacement by time. Okay, so the displacement, time t is equal to 0, the position is 0. Time t is equal to 9 seconds also, the position is 0. So the displacement goes to 0. So the average velocity also 0. Okay, so E is correct. So B, C and E are correct statement. So B, C and E, option 4 is the right answer. Okay students, we came to the end of the session. If you have any doubts or queries regarding this video, please do comment it. And to watch more video like this, like and subscribe our channel. Thank you students.